What's up, Algebra 2 students? All right, so I went over a few examples of completing the square in class last time you were in class, and I wanted to go through a few more so that you guys could try some problems on your own. So remember, the idea of this is we're trying to go from what's known as standard form, and we're trying to turn it into vertex form or graphing form, right? This is a very kind of nice little trick, especially if you're trying to graph a parabola very, very quickly, okay? So quick reminder, the first step is we're going to move this forward to the other side because we want to pick our own number that will make a nice little completed perfect square on the right hand side to make it more like vertex form. So here we go. Subtract 4, subtract 4. I'm going to end up getting y minus 4 equals x squared plus 8x, and then I have this gap here. As we talked about last time, because we do want a perfect square, right? We know that we're going to have like x times x to get the x squared part. But what we realized in class was that if we took two numbers here, a number here and a number here, they both add up to this middle term, but they multiply to get that other term, right? So what's two numbers that would add up to 8? Same numbers, right? But also, what would those be? And then what would they multiply to get to that? If you said a positive 4 and a positive 4, you are absolutely right. It would just be x plus 4, right? But in order for this to work, this number over here would have to be a positive 16. So what I'm going to do to make everything balance is I'm going to add 16 to the right side, but I'm also going to add it to the left side to keep things balanced, okay? Now I'm going to simplify this left side here. 16 minus 4 is going to be 12, right? So y plus 12 equals x squared plus 8x plus 16, or again, because we know this factors to this, we can go ahead and write x plus 4 times x plus 4. Better way of writing that would obviously be x plus 4 quantity squared, and even more better would be to get the y by itself, so it's in graphing form. So I'm going to subtract 12 to this side, and this would be my final answer for vertex form, right? This would be a parabola shifted to the left, down 12, opening upwards because, again, this no negative out front, and that would be a quick way of doing that, right? Let's try to do this next one, okay? So same idea. We take this 16, move it to the other side. So subtract 16, subtract 16. We get y minus 16 equals x squared minus 16x. And I am trying to figure out, again, maybe I'll go one down, what is going to make this a perfect square, right? I'm looking for what would that number have to be. Now, again, a little cheat sheet here. I'm looking, again, two numbers that would add up to get negative 16. Same numbers, right? But would multiply to get, well, what? So again, we were always noticing that this number is always going to be half of what that is, right? So half of 16 is 8, right? So 8 and 8 make 16. But because this is negative, we'd probably want to make both of these negative 8, right? That way, if we multiply negative 8x and another negative 8x, we'd get negative 16x, right? But what would that number have to be to make all this work? Well, 8 times 8, that's going to be a positive, 64. So I'm going to put a plus 64 over here. Now that we would know is going to factor down to this perfect square, right? Because we know that this foils out to that, right? But in order to make this algebraically make sense, we are going to have to make sure that we put the plus 64 on both sides, right? So this is going to be that balancing act that allows us to do that in the first place, okay? So we're going to clean up the left side. 64 minus 16, let's see here. 64 minus 10 would be 54 minus another 6 would be what? 48? All right. So we got y plus 48 over here. And then we're just going to go ahead and rewrite this as x minus 8 quantity squared. We can then go ahead and subtract 48 both sides. And we have our answer. Now, something I want to just talk about real quick. There's a lot of textbooks and a lot of help online that's going to help with you picking this number, especially if you're not catching the drift of what I'm doing here. The thing that they're going to be telling you is they're going to say, remember this equation. They'll say something like b over 2 and then quantity squared, right? And let me explain what they're doing here. So the reason why they picked the letter b is because normally in these quadratics you get like y equals ax squared plus bx plus c, right? So if we're trying to figure out that magic number, right, one way to do that is look at the b term, aka that negative 16, the one that we've been doing, right? Divide it by 2 and then square it, right? So that is kind of the shortcut way of picking out what that is. I'm going to show you really what that means in the next problem, okay? But this is something that you might see in math notes or those like tutorials online as kind of a cheating way of figuring out what that magic number is, so you know what to add to both sides, okay? There's another thing that's nice about it is if you divide the b by 2, that's going to tell you what these numbers are to help you with this part. So this is actually not a bad thing to kind of know about, okay? So without further ado, I definitely put that in my notes. Let's try one. As you noticed so far, my b, or this middle term, is always even, which makes it really, really nice when we're cutting it in half, right? I would like to do one where it is not so easy. So here comes the fractions, baby. Here we go. So same as before. Let's add 1 to both sides. We're going to get y plus 1 equals x squared plus 5x, and then obviously this cancels. Now normally, again, I'm thinking of it, you know, with the equals, parenthesis, 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 right, x and x. I'm thinking of, again, something that adds up, right, to get that, because that's going to be the relationship that I'm looking for, that perfect square. You'll notice that this time, unfortunately, I am going to be getting a bit of a fraction or a decimal, right? So because I don't have a calculator privy to me, I'm going to do this with fractions, but the idea is it's going to end up being 5x, right? And it's going to be half of that. Now, you guys probably would say, well, that's 2.5, right? Well, fraction-wise, let me bring this formula back into this. I can actually figure out what the number I need to make here and here is by just running this formula. So taking this b term, if I just plug it in here, so 5 over 2, first of all, that 5 over 2 actually is what ends up becoming this and this. 5 over 2, by the way, is just 2.5, right? 5 over 2 squared is the same thing as 5 over 2 times 5 over 2. And that is just going to be found by multiplying 5 times 5 and 2 times 2 straight across. So 5 times 5 is 25, and then 2 times 2 is 4. So 25 over 4 is that magic number that needs to be put on both sides. And I think that number is, don't quote me on this, but I think it's 6.25. But we'll just do fractions to make it a little bit more legit, right? So here we go. I'm going to add 25 over 4 to both sides. This, by the way, would be a much harder problem because of the whole fraction thing, but again, one step at a time. So the thing that, again, that goes into here, again, is half of 5, so 2.5, or you can just include the 5 over 2. So I'm going to just go ahead and put plus 5 over 2. We'll leave it in fraction terms. You guys can do decimals if you ever run into this scenario, if you'd like. Now, to be able to add these, right, I need common denominator, so I'm going to do a little bit more steps than I normally would. I would have 25 over 4 plus y. To make this adaptable to add with 25 over 4, I would have to give 1. Think of it first as a fraction, so that's 1 over 1. I would have to give it the same denominator as that, so I actually would have to multiply it by 4 over 4 to make it even the ability to add these together. So I'm going to add 4 over 4, because 4 times 1 and 4 times 1 is 4 over 4, right? I'm going to add that to 25 over 4. What I'm going to end up getting is y plus 29 over 4, because when you add two fractions, the denominators stay the same. You just have to add the top. Equals, I can rewrite this as a square, right? And then I just move that 29 over 4 to the other side, okay? And again, this could be done with decimals if that makes you feel a little bit more comfortable, right? But this would definitely be a little bit tougher of a problem. Not my favorite problem to do, to be honest. And I don't think anybody's like really excited to do fraction type stuff or decimals, but it is possible. I know some people might ask like, well, what if the middle term isn't even? What if it's not nice? Well, it works really, honestly, for any number, okay? So that would be an example of a odd middle term. All right, last but not least, and this is just one to think about. We'll do more of these examples together because this is definitely probably the most challenging. I wouldn't say it's the most challenging, but there's definitely there's one part to this problem that is going to be tricky. But what would happen if there's a term in front of x? Because again, another thing we haven't done is what happens when the number up front is something different than 1, right? So here is what we're going to do. Same as before, we're going to move this 3 to the other side. So plus 3 plus 3. Okay, so I'm going to get y plus 3 equals 3x squared plus 12x. Now, this is the part I need you to follow me with, okay? By completing the square, it is much easier to not have this 3 out front, okay? So I'm going to need you to listen up here. I am going to need to take out or divide out something that is common between these two numbers, right? So think of the number out front, think of this number out front, and tell me what goes into 3 and what goes into 12? What can we divide 3 and 12 by? The same number. And if you guess 3, you're absolutely right. So here's what I'm going to do. I'm going to do y plus 3 equals, so I'm not going to do anything to that side, but I'm going to take a 3 out. This is what's known as factoring out. I'm going to factor out a 3 from each of these, aka divide a 3 to both these. So 3x squared divided by 3 is, well, the 3's would cancel. You just get x squared because 3 divided by 3 is 1. And then I'm going to do 12x divided by 3, which is 12 divided by 3 is 4, right? So that would be positive 4x, okay? So what you're seeing here is I'm turning this into a normal factoring problem, or a normal like completing the square problem, where it's just x squared, it's just a number in the middle, and I just have to guess this one, right? But the only difference is now there's a 3 out front, okay? So that is one of the first main differences. The second main difference, and this is the weird part, you're going to do what you normally would do, right? You're going to just go write everything like you would, 3 parentheses. Now think of it as, x and like what are two things that, would add to this, right? But that are half of it, right? If you would like, you can even use that formula now, that b over 2 squared if you're trying to figure out what that number is. So 4 divided by 2 squared, which is really 2 squared, right? That number 2 would be the number that goes here, and then 2 squared would be the number that goes there, okay? So we're going to put a plus 2 and a plus 2. Notice those things will have to add up to that. And then 2 times 2, that would give me that 4 here. Now, here is the part everyone messes up. So I'm put a big warning flag on this one. I would pause the video, put like 400 stars next to your notes here. I am going to put the plus 4 here. Now, your brain is going to say, all right, put a plus 4 here, and now I'm going to put plus 4 here. But unfortunately, if I put a plus 4 here, that is technically against the rules. And let me explain why. If I put a plus 4 here, and I put a plus 4 here, that would be uneven. The reason being is there's a 3 that is technically still being multiplied to each of these 3 numbers, right? So really, this isn't a 4. This is really a 4 times 3. So to kind of make the balance of this equation even, I'm going to have to put a 4 times 3 on the other side. Not a 4, but a 4 times 3 because of this outside 3, okay? I'm going to say it one more time. I am not going to be putting a plus 4 here. I'm going to be putting a 4 times 3 because of that extra 3 up front. You normally wouldn't have to do that because you normally don't have this extra 3. So 4 times 3 is 12. So I'm going to add 12 to the side. And that is that secret sauce. And I don't think people like that because it seems unbalanced, right? How do I put a 4 here but a 12 here? That doesn't make any logical sense. But it does because this 3 is multiplying to each of these, making this a 12, not a 4, okay? So I am going to kind of finish up this problem. So here would be the 12, right? I'm going to combine like terms. It would be y plus 15 equals 3. I'm going to, write this as a square, x plus 2 quantity squared. And then last but not least, I'm going to move this 15 over, okay? So this would be a extremely advanced example because of all the moving parts. But this technically would be the last example you would need to see to pretty much be able to do any type of completing the square or going from standard form to graphing form that you could actually be thrown in the algebra world. So hopefully this makes a little sense. I have a few problems lined up for you guys to practice. You have a wonderful day, and I'll talk to you later. Bye.